tech diet. Let's dive into our today's problem. Check if it's possible to split array. It says you are given an array of nums of length n and an integer m. You need to determine if it's possible to split an array into n non-empty arrays by performing series of steps. In each step, the length of subarray is 1, that's a valid split, or the sum of elements of the subarray is greater than or equal to m. We need to return true if we can split the given array into n arrays, otherwise we can return false. So for example, let's take this test case. Our m is 4, so we can split it as 2 2 and 1. So that is a valid split because it says one element, and 2 and 2, these are more than one element, but the sum of element is 4. So further we can split 2 and 2. This is again a valid split because it just has one single element, so all the elements can be splitted. So at last we have three subarrays with this qualification, so that means it's possible to split the array. Let's take another example where we have this 2 1 3. So for this our m is 5. We can say, can I split 2 and 1 3 in 1? So 2 will be single, 1 3 4, 4 is less than 5, I can't do that. Can I do 2 and 1? 3 in 1 I can do, 2 and 1 I can't do, so I can't make a split. So that means it's a false. We can't split the array into n unique subarrays, so that it qualifies a condition. Similarly, let's take an example of this. We have m as 6, so let's just split it. Let's keep 2 here and 3 3 2 3 here, that is valid. And then we can split this person. We have 3 3 2 3 here, and then we can have 3 2 and 3, but this will be invalid split, right? So I can't go there, so I had to restart. So let's just wipe off the last end. So we have here 2 and 3 here, and then we have 3 3 and 2, and then we'll have 2 here, and then we'll have 3 3, then finally we'll have 2 3 3, right? So we will split it again, so that means we have it is possible. So you see, it's a pattern, like either we can clip the first element or we can clip the last element off. So it's a decision whether we can split the array into n equal n elements based upon the criteria. So let's just simulate this situation using our, either we clip it from the left hand side or we clip it out from the right hand side. So okay, let's have a helper function. We'll pass the list, the given list. We'll pass initial I and j, or start and end maybe. So let's just pass start as 0 and as the size -1 and our m. So let's just have a size here which is this public. For now let's keep it void, and we'll be passing our list of integer. This is list, this is start, this is my end, this is m, and here we can say, can I split okay, let's first calculate the sum of the elements, the given elements. So for that we'll have in the list sum plus equal to re. Let's have this sum here, and let's pass this sum here. So now let's make a split. So int temporary sum1 is will be equal to list dot get the start element. Let's clip off the first one, so we'll land up with some minus this guy, and we can say if my temporary sum1 is greater than or equal to m, then it's a valid split, because anyway the other one is 1, the leftover sum should be greater than equal to m. That's our condition. We can call this helper method again on the same list, with our start will be start plus 1 and will be same, sum will be the temporary sum 1, and then rm. Similarly, we can wipe off the end part, that will be a sum 2. If this is a valid split, my start doesn't change, my end changes, the sum changes, so that's it. Okay, let's return a boolean here. So let's just say we have a boolean out1 is equal to false and out2 is equal to false. Here let's update our out1, let's update our out2, and we can return out1 or out2, whichever returns true we can break it off. So here we can say if my start, let's just say end minus start is equal to 1. So we have landed into situation where we have this 3 comma 3 or 2 comma 2, we have two elements. We can definitely make a split always, because we will land into one element, that is again the valid subarray. So we can just return true from here. And we can say if my sum, if my sum is less than m, I should return false. Okay, let's just return this and check our simulation. So it's returning true, we should return false. Okay, where it's failing, we are size should be list dot size. Let's just run it again. Okay, it's getting passed now. So now you see we are computing, we're trimming it off either the first element or the last element. There will be scenarios where our start and end are recomputing the same thing over and over. So let's just show you a couple of smaller sub problems. So we'll have this start and end. Let's print it out. So in our case, we have 0 and 4, 1 and 4, 1 and 3, 1 and 2. So this 1 and 2, 1 and 2 is computing many times. So we just want to compute it once and maybe store that result. So 1, 3, 1, 3, all that series is repeated. So we want to get rid of that. So let's just add our DP here. So we can probably add a boolean DP. It's, let's say something like this boolean, and here DP will be new boolean, the corresponding size, and at each iteration we can say DP of I is equal to new boolean size. So here we have our I pointer initialized, and after each iteration we can increment it. So we have our DP initialized. We can just check if DP of start and end isn't null. We can simply return our start and end. We don't need to recompute the sub problem. Otherwise we can set it here, and is equal to our out 1 result and out 2 result. So here we can happily return the value stored for this particular computation. Let's just run it again. Yep, let's try to hit submit. Okay, this is accepted. Yep, there's one another way we could solve this problem, that is quite an observation. Like for this test case we have 2 2 and 1. For this test case we have 2 3 3 2 3. So in our computation of this, we remember, like, we clip off the last element and then we clip off the last element. At this stage we clip off the first element, so that I remain with the subarray which has sum greater than equal to 6. So that means if I always have any subarray whose sum is greater than equal to given m, then I'll always make a valid split. So because I need to make sure that this subarray can never be splitted unless it just remains the two elements. So with that being said, what we can do, let's just try if this approach works. We can just say if for the given list int I is equal to 1, I less than my list dot size I plus plus, int, let's say previous element will be list dot get I minus 1, and int current will be list dot get I. If previous plus current is greater than equal to m, we have found one pair, one consecutive pair which is satisfies the condition, then it's true. Otherwise, if we haven't found any pair, it's false, because that means there's no subarray whose sum is greater than equal to m. So let's just try to run it. Okay, let's try to submit this. Okay, so if we just have one element, that's the corner test case, so we can just say if the list dot size is less than equal to 2, we can always return true, because if it is two size we can split into 1 and 1, that is also a valid criteria. So we'll run it again, we'll submit. Yep, this again works, and this runtime is 1 millisecond, which is better. So yeah, thank you.